this little animation, this is a great animation that shows you what a radian is. Okay, a radian. So a radian is a different unit of measure for angles. So angles can be measured in degrees, or they can be measured in radians, kind of like inches and centimeters, like one metric. So they're different units of measure. So there's two. If you have an angle, there's two different ways that that angle could be represented. Okay. So let's look at this. Let's look at this animation. So we have a circle. It's going to show you the radius. So here's our radius. Okay? The radius creates that circle. If you took that radius and you laid it on top of the circle, that angle that arc creates is 1 radian. That angle that arc creates is 1 radian. When you get right here, that's pi radians, because it's 3 and a little bit radians. Every single time. It doesn't matter how big or how small the circle is. Okay? Pi is a direct ratio of the circumference divided by the diameter. So if you take any circle and you take the circumference and you divide it by the diameter, you'll get pi. Every single time. Some genius figured that out. But every single time, it doesn't matter how big the circle is, if you figured out the circumference and you divided it by the diameter, it would always equal 3.14159, blah, 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 blah. And then they named it pi. So that, because it had a special relationship. Okay? And so, any circle you have, there's 3.1415, blah, 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 radians from 0 to 180. Okay? So 180 degrees is the same thing as pi radians. Pi is always radians. Okay? So I just thought this little animation was great to explain what is a radian. How did they get a radian? So if you took the radius and laid it on the circle, that angle that creates that arc is 1 radian. That's what it means. Okay? Okay, so we looked at an animation of what is a radian, okay? But let me explain it like this. Maybe it'll help you to remember it easier. Let's think about this. How many degrees are in a circle? 360. So if I go all the way around the circle, it's 360 degrees, right? Okay. What is the circumference of a circle if the radius is 1? So let's say the radius is 1. The circumference, what's the formula for circumference? Pi r, no, not 2 pi r, or pi times d. Pi times the diameter, right? 2 pi r and pi times d, those are saying the same thing, okay? So the circumference is 2 pi r. So what if our radius is 1? What's the circumference? If our radius is 1, the circumference, well, you just leave it in terms of pi. If the circumference is 1, that means if the radius is 1, the circumference is 2 pi. So all the way around, y'all told me was 360. Well, we go the other way. And the circumference, if the radius is 1, is 2 pi. So 360 is the same thing as 2 pi. This is the beginning of what we call the unit circle, right? And in the next 2 sections, we're going to talk more about the unit circle. It's going to become integral. What it is you take a circle and you put it on a coordinate plane. The center is at 0, 0. The center of the circle is at 0, 0. And the radius is 1. Okay? And so if that's our unit circle, if that's the circle we're talking about and the radius is 1, then the distance all the way around is 2 pi. Pi is radians. Pi is always radians. If it tells you an angle measure and it says it has pi in it, that is radians. They're not going to write radians after it because you're supposed to know pi is radians automatically. If it has the degree symbol, it's degrees. If it doesn't, It's radians. Okay? Now, if you didn't copy this down, don't worry about it. You don't have to memorize this. You will later in pre-cal. You will have to memorize this. In pre-cal, you will have quizzes on this because this unit circle is very important. But in Math 3, you don't have to memorize this. We just need to understand where these values come from. Okay? So we showed that from 0 to 180, that was pi. We showed that in the animation, right? Okay? Because that's 3 and a little bit radians. Okay? All the way around is 2 pi. Well, the special angles that they talk about are 30, 45, and 60. Okay? 30, 45, and 60. If I took, this is 30 degrees, right? That's 30 degrees. And according to this unit circle, 30 degrees is pi over 6. All right? Now, let's see how that makes sense. If I separated this 180 degrees into 6 sections, 180 degrees is pi, right? So if I divided it into 6 sections, which means every section is an increment of 30. So then it would go, pretend like the rest isn't there. It would go 30, 60, be 3, 6, 9, all the way to 180. There's 6 of those sections. It can be divided into 6 sections if you go in increments of 30. So that's pi divided by 6, because all the way to 180 is pi. So if you divide it into 6 sections, each section is 30 degrees. Does that make sense? So if you took the same one and you did 45 degrees, if you went in increments of 45 degrees, so then it would be, that's halfway, right? So if I went in 45 degrees, then it would be broken up into 1, 2, 3, 4 sections. So 45 degrees is pi divided by 4. Y'all see that? And if I did in increments of 60 degrees, then it would be 60. 60 times 2 is 120, and times 3 is 180, right? So there would only be 3 of those sections. So 60 degrees is equivalent to pi divided by 3. Does that make sense? So that's where all those radian values come from. Okay, it's taking pi and dividing it by however many of those sections are created. Okay? Now, what we're going to have to do in the first set of problems is we're going to have to convert radians to degrees and convert degrees to radians. That's important because the 2 formulas that we use today have what we call theta in it. Theta looks like, it's the Greek symbol that looks like that. Theta represents an angle measure. But for our formulas, that angle measure has to be in radians. So if they give it to you in degrees, you have to convert it to radians to work the problem. Okay? So in order to do that, we have to go back and forth between degrees and radians. Okay, so if we want to go from radians to degrees, I want you to dig deep back into your elementary school brain. And when you had to do unit conversion, okay, if we wanted to convert, say, quarts to gallons, so if we wanted to convert it to gallons, you would multiply however many quarts you have. Okay, you don't need to write this down. This is just an example. So if we had so many quarts, and we wanted to convert that to gallons, you would multiply by gallons over quarts. You would have to multiply times gallons over quarts because after you multiply straight across, your quarts cancel, leaving you with just gallons. Does that make sense? That's unit conversion. Okay? If you wanted to convert inches to feet, we had 220 inches, and we want to know how many feet that is. You multiply it times feet over inches. In 1 foot, there's 12 inches, right? When you multiply the numbers, your units cancel, leaving you with just feet. That's how we do unit conversion, and that applies to anything. It also applies to degrees and radians. So if we have degrees and we need to change it to radians, yes.
Why did you cancel that? It's like 12, but that's 220.
I didn't cancel 12 and 220. I canceled the units, the inches. Okay? Then you would do 220 divided by 12, and that would tell you how many feet that is. Okay? Do you understand? Tell me, do 220 divided by 12. I should have finished the problem.
18.323.
Okay, so this is 18.3 feet. You know to divide by 12, but you probably don't remember that you're doing that because you're canceling those units. So the inches cancel, leaving me with just feet. Yes. Okay, so let's go back to degrees and radians. So if I have degrees and I want to convert it to radians. So if I have degrees, then I need to convert that to radians. I'm going to multiply it by radians over degrees. I'm going to multiply it by radians over degrees because what's going to happen? My degrees will cancel, leaving me with just radians, correct? But what is this conversion? How many radians equal how many degrees? Pi radians equals 180 degrees, right? So you multiply that times pi over 180. So if you have the degrees, say 50 degrees, and you want to change that to radians, you take 50 and you multiply it times pi over 180. Okay? And that's what we have here. So if we're going from radians to degrees, however many radians you have, you multiply it times 180 over pi. Think about it like this. Whatever you're changing it to, that is what goes on top. If you're changing it to degrees, degrees has to go on top. If you're changing it to radians, pi has to go on top. Okay? Because when you're changing it to degrees, these radians, because this is pi radians, these radians will cancel, leaving you with just degrees. Okay? Does that make sense? Okay, so when they give it to you in degrees and they tell you to change it to radians, if you're changing it to radians, you multiply times pi over 180. If they give you the radians and you're changing it to degrees, you multiply it by 180 over pi. Now, the first set of problems in your book has you go back and forth between the two. If you're changing it to radians, the answers in the back of your book are exact answers. Meaning, they leave it in terms of pi, okay? If you actually use your calculator to multiply times pi, pi is an irrational number, correct? So, you're gonna have to round off. And when you round off, it's not an exact answer anymore. So, when we look at our first problem, change 330 degrees to radians, okay? So, we're gonna take 330 degrees. We're going to multiply that times, if we're changing it to radians, what do we multiply by? Pi over 180. Okay? Pi over 180. Now, that's the same thing as 330 pi over 180, right? If they want an exact answer, which they do in your book, they want an exact answer. If not, they would say round your answer to the nearest tens or hundredths. Then all you have to do is take your calculator and you're going to do 330 divided by 180. That's going to give you a decimal. Change it back to a fraction. That'll give you the reduced fraction. Because all you have to do from here is reduce that fraction. So if you don't want to reduce it by hand, use the calculator to reduce it. Because your answer, for it to be an exact answer, has to be in terms of pi. You see what I'm saying?
Does our
Okay, so when you reduce 330 over 180, you get 11 over 6. So 11 pi over 6 is your answer, because I know it's radians because it has pi in it. If I actually multiplied that out, I would get some decimal that I'd have to round off. And when we do the calculations, like when we're finding arc length and area in a minute, you're going to have to actually multiply that out and round off to the nearest hundredth. Then you need to write the word radians, because without pi, we don't know it's radians. Okay? Any questions on how I got 11 pi over 6? Okay? No questions? Okay, this one says change 2 pi over 3 to degrees and then draw the angle. Now, if I told you to draw the angle 2 pi over 3, 2 pi over 3 is an angle measurement. It's just in radians. Unless you memorize that unit circle, you don't know where that is. Okay? But we have the ability to change it to degrees, and then we can draw where that angle belongs. Okay? So take 2 pi over 3, change it to degrees. Okay, did y'all change it to degrees? What'd y'all get? 120. Good. So we have 2 pi over 3. That's our in radians. If we're changing it to degrees, thank you. We multiply times 180 over pi. Okay? Now, make your life easier and cancel the pi's. You don't need to multiply by pi and then divide by pi, right? Because that's just, they cancel out. So now all you're doing is 2 times 180 divided by 3, and you get 120 degrees. So 2 pi over 3 is the same thing as 120. Now I know where 120 should be. 120 should be between 90 and 180. Now, we draw this little arrow to show that we started at 0 and it came to here. This is 120 degrees. So that's how you draw that angle. Okay, any questions? No questions? We're good? Okay. Now we're going to talk about arc length. There's 2 formulas you're going to have to memorize, and they're easy formulas. Okay? Arc length is not to be confused with the measure of the arc. Okay? The measure of the arc, so we have an angle here, I'm going to call it theta. Okay? If theta was 50 degrees, the measure of that arc would be 50 degrees, because the central angle is equal to the measure of the arc. God bless you. This is the length of the arc. Okay? If I needed to find the length of the arc that was the whole circle, what's that called? Circumference, right? That's the circumference. The length of the entire circle is the circumference. The arc length is just a small piece of the circumference. It's just a piece. It's the distance, the physical distance. How many inches? How many centimeters is that? Okay? So arc length, the formula is S equals R times theta, where theta is the central angle in radians. Okay? There's another formula where it includes that angle in degrees, but it's kind of long and complicated. So I don't see the point in having you memorize 2 different formulas for arc length. Just memorize this one. It's the short one. It's just if they give you that angle in degrees, you have to change it to radians before you can plug it in. Okay? So S equals R times theta. I have no idea why they use the letter S, but they do. S represents arc length.
Wait, what?
Arc length is represented by the letter S. So the arc length equals the radius times theta. Theta is your central angle in radians. Okay? All right. Let's look at a few problems. It says find the length of each arc. If you see the word length, that means you need to use your arc length formula. S equals R times theta. S equals R times theta. S equals R times theta. Arc length equals R times theta. S equals R times theta. Always write down the formula first. Look at the question. What are they asking me to do? They're asking for the length of the arc, so write down the arc length formula first. Now, let's fill in the information that we need to find the arc length. Well, I need the radius. What's the radius?
5.
5. And I need theta. Theta is the degree measure in radians. They don't give it to me in radians. They give it to me in degrees. I mean, the angle measure in radians. They give it to me in degrees. So you have to go change 50 degrees to radians before you can plug it in right here. Okay? So theta equals 50 times what over what? Pi over 180. Now, when you're finding area and you're finding arc length, round any values that you need to the nearest hundredth before you plug it in. Okay? That way we all get the same answer. Because if you round to the nearest tenth and I round to the nearest hundredth, our final answer is going to differ. Yes? S is the arc length. No, 5 is the radius. Five is the radius. The angle measure is 50. Okay? We have to find the circumference of that little tiny section. Okay? Round to the nearest hundredth. So 50 times pi divided by 180. Now, I would use the fraction button. Alpha y equals, use the fraction button. 50 times pi divided by 180, 0.87. 0.87 radians. We just changed it to radians. 0.87 radians. Okay?
How'd you put it in the calculator?
I did like this. I used the fraction button, and I did 50 times pi over 180. Okay? And then you get 0.87. All right? So theta is 0.87. Now all you have to do is multiply 5 times 0.87, and you get the arc length. .35. Now, centimeters. Very good. That's what I was going to make sure you add. That's an actual physical measurement. So you need to put centimeters. If it tells you the radius is so many centimeters, then your arc length is so many centimeters. Okay, what'd y'all get for B?
6.9.
6.09 centimeters, right?
Yeah.
Everybody got that? And C? 12.25. Okay, let's look at B. S equals R times theta. So S equals 7 times theta. Where we found 50 degrees. We changed that to radians already over here. That's 0.87. So S equals 6.09 centimeters. Any questions on that? All right. And for C, S equals R times theta. So S equals 7 times whatever theta is. Well, we have to find that. Theta equals 100 times pi over 180. So theta equals 1.75. So when we multiply 7 times 1.75, we get S equals 12.25 centimeters.
So we started.
Yes.
If we do it the other way and like this.
Okay, so work these two. Okay, so you should have gotten, or something very close to 11.15 for number 1 and 15.26 for number 2. So, shh, find the length of the arc. S equals R times theta. S equals, the radius is 5. Theta, you have to find it. Theta is 128 times pi over 180. So theta equals 2.23 radians. So when you multiply, you get 11.15 centimeters. Any questions on number 1? Number 2, find the length of the arc. S equals R times theta. S equals, they give you the diameter is 14, so the radius is 7 times theta. You have to find it. Theta equals 125 times pi over 180. So theta equals 2.18 radians. So S equals 15.26 inches. Any questions? That's fine. Your answer should be very close to this. Okay? Any questions? Okay. So we found a piece of the circumference, right? That angle created an arc, and we found the length of that arc. So that was a piece of the circumference. Now what we're going to do, we still have an angle. We have a central angle. And we're going to find the area of that sector. Area of the sector just means we have this angle right here. Call this theta. We're finding a piece of the area. If we had to find the area of the entire circle, it'd just be pi r squared. Okay? But it's not the area of the whole circle. It's only the area of that little section. This is called a sector. It's the section that's created by that angle. Okay? So you just they say find the area of the shaded region. That's when you use this area of a sector formula. The area of a sector is 1/2 r squared theta. And again, theta has to be in radians. 1/2 r squared theta. So just like the arc length, you need the radius and you need the central angle in radians. Okay? So example 1 says, find the area of a sector. Find the area of a sector. I'm going to write area equals 1/2 r squared theta. If the central angle is 5 pi over 6, so the central angle is 5 pi over 6, what does that represent? Theta. Theta. It's already in radians. There's nothing to convert. So that's theta. So area equals 1/2. It has the diameter is 32, so what's the radius? 16. So it's 16 squared times 5 pi over 6. You put it in your calculator just like that. Everybody got it? No? Okay, come on. Use those fraction buttons in your calculator. Make that easier. It is. 335.10. Who got that?
Yes.
I did.
So did somebody second that? Third that? Yes, that's correct. Correct. 335.10. What's my unit? Centimeters squared. It's area. Centimeters squared. Square centimeters.
Is it necessary to put the 0?
No, it's not necessary to put the 0. You could do 335.1. You want to round them to the nearest 100. Okay? So that we're all on the same page. Okay? So you have to change, theta is in degrees, you have to change it to radians. You get 1.4. So your area is, oh, I forgot my unit. 11.2 feet squared or square feet. Any questions? Okay. There's 3 more problems that you need to work. And with these problems, they don't give you the diagram, they give it to you in words. However, problem 2 and problem 3, you have to go and find the information that you need because they don't give you the radius. So you have to go figure out how to find the radius. Okay? So let's look at those problems. I want y'all to try to work those. Okay, so be careful with number 2 and 3. They give you the central angle, but they don't give you the radius. So you have to figure out how to find the radius. Also, when you're looking at number 2, it tells you the central angle is 0.74. Do you see a degree symbol? No. So it is not degrees, which means 0.74 has to be radians. If it doesn't have the degree symbol, you are to assume that that is in radians. Okay, for number 1, theta is 55 degrees. We have to change that to radians. So 55 times pi divided by 180 is 0.96. Now, find the arc length. What's the formula for arc length? S equals R times theta. So S equals R is 4, theta is 0.96. So the arc length is equal to 3.84 inches. What's the formula for area of a sector? 1/2. I knew what you meant. 1/2 R squared theta. So that's 1/2 times 4 squared times 0.96. So area equals 7.68 square inches. Any questions on those two? Okay. Number 2. Look at what it's asking. We have to find the area of a sector. What's the formula for area of a sector?
1/2 R squared.
Excellent. 1/2 R squared theta. Now, let me fill in what we need. So, area equals 1/2. I need the radius, and I need theta. Okay? Well, let me see. They didn't give me the radius. I don't know what that is. Do I know what theta is?
Yeah.
It's 0.74. 0.74, I don't see a degree symbol, so I know it is in radians. So 0.74. Okay? So, they didn't tell me the radius, so they had to have given me a way to find it. Well, let me see what other information they told me. They said a sector has an arc length of 22. If I know the arc length, and I know theta, I can find the radius. Arc length, S equals R times theta. What's S?
22.
22 equals R times 0.74. So now I just divide both sides by 0.74. And 22 divided by 0.74 is 29.7, what? 3. 29.73. So now I know the radius, I can find the area. 29.73 squared. So I plug that in, and you should get area equals 326 point what? 326 point what?
327.
Okay, 320. Okay, so 0.5 times 29.73 squared times .74 is
11.6.
327.03. And I don't know inches or centimeters or whatever, so I just have to leave it like that. Okay? Any questions on number 2? Number 3's worked exactly the same way. Find the area over sector. So I'm going to write area equals 1/2 r squared theta. Area equals 1/2 times the radius squared times theta. Well, they told me theta is 0.95. Central angle is 0.95. I have to find the radius. They tell me the arc length is 16. S equals r times theta. So 16 equals r times 0.95. Divide both sides by 0.95. 16 divided by 0.95 is 16.84. So I take 16.84 and I fill that in, and now I multiply. 0.5 times 16.84 squared times 0.95, and I get 134.70. How'd we do? Good. Any questions? Okay, so your homework is page 781, 45 through 75 odd, and then number, God bless you, 89 and 90. For that first set of problems, when you have to convert from degrees to radians, I want you to check your answers in the back of the book. They're exact answers. They're not rounded off. So all your answers should be in terms of pi. So you just have to reduce your fraction. There'll be something pi over something. Okay?